Let's talk about another characteristic of ratio and proportion. There is 3 points for the concept of ratio and proportion. First of all, ratio is expressed as a simplest integer. Okay? What does it mean? For example, if there is the ratio of 50 to 20, it is expressed as 5 to 2. You know, it became simplified, right? Because this is a rule, because it is very easy to grasp the idea, you know. As the number goes larger and larger, the more difficult to understand, to grasp the idea, right? Second of all, when you express the ratio in a fraction or decimal points, you convert those fraction and decimal to the integers. It's always integer because integer is the simplest number you can understand, right? For example, okay, I will give you an example later, okay? So fractions or decimals of ratio convert to the integer. So this one is the simplest integer. Likewise, these fractions and decimals should be converted to the integer, simplest one, of course. And third of all, the inner product of ratio equal outer product of ratio. Okay, inner product of ratio equal outer product of ratio. I will let you know. I will teach you. I will show you what does it mean. Okay, let me review what the ratio is. Ratio is a methodology of measuring or comparing more than two objects. Okay? And the ratio is expressed as the simplest integer. For example, there is 50 people and 20 people. You make it simple to the ratio of 5 to 2. So you divided these numbers by 10, because number 10 is a common divisor for all numbers, you know. So 1 over 10 times 1 over 10. This is it. Let me give you another example. So, for example, there is 900 yen and 300 yen. Describe the ratio of these price of value of currencies. Yen is Japanese currency, okay? Because I live in Japan. So the question is, express these numbers in a ratio. So tips for one tip for this problem is you find the greatest common divisor, because by using greatest common number of 900 and 300, the end product becomes the simplest one. Okay, let me conduct the calculation, okay? So first of all, just make them in a row. The ratio of 900 at the ratio of the 900 to the 300 is, okay. Instantaneously you realize it is divisible by 100, right? So at the ratio of 9 to 3, but you can still divide these numbers by 3, right? So it's end up 3 to 1. And as you can see, you divided by 2 two numbers, which is 100 and 3. So 100 times 3 equals 300. So 300 is the greatest common divisor, isn't it? So without using this pathway, you directly reach to this end product by using 300 as a greatest common divisor. About ratio, you can multiply or divide by for these numbers by the same number. For example, you can multiply 6 and 2, 3, 1, whatever. The thing is, the end product never change as long as you divide or multiply the same number to the both numbers, because this is proportional. This is the equilibrium. It is maintain equilibrium, right? And as we talked before, as a point 2, when these ratio two numbers of ratio expressed as a fraction or decimal, you make this number integer. Why integer? Because it's easy to understand. It's easy to see. Rules are made for better usage. This is a key idea anytime you study mathematics. Okay. So let me give you an example of the fraction in the cases of a fraction and decimal point. So example number 1. There is a ratio at like this. So at the ratio of 1/3 to the 1/5. In this case, unlike previous question, now we use a greatest common multiplier. Why? Because we would like to multiply these denominator, so that you can make an integer. Okay. So can I say what's the greatest common multiple of 3 and 5? That is number 15. Okay. Number 15. So let me say, so 1/3 times 15 to 1/5 times 15. As I just told you, you can multiply or divide by these numbers by using the same number. Okay, so this relationship never change as long as you multiply, divide, add, subtract, blah blah blah. Okay, now you can make an integer. So this is 5. This is 3. So the ratio ends up as 5 to 3. At the ratio of 5 to 3. Isn't it easy? Okay, there is another example, which is for denominator. Okay, let me say there is a ratio of 0.8 to 3.2. So in this case, you just multiply by 10. Okay, because anytime you multiply these numbers, this is gonna be an integer, right? So 0.8 times 10 to 3.2 times 10 is 8 to 32. Yeah. And now you can make it simpler. This ratio is simpler by dividing by 8, right? So 8 divided by 8 is 1. 32 divided by 8 is 4. So it is 1 to 4 ratio. Okay. Okay, now let's talk about the inward product and outward product. Inward product and outward product. So in the formula of ratio, you can say such a thing. So let me give you an example. To B at the ratio of A to B equal at the ratio of C to D. So multiplication of inward numbers. So it means B to C is equal to the multiplication of outward numbers, which is A times D. In other words, B times C, okay, BC equal AD. There is such a relationship. So, another example I'm going to tell you. There is a ratio, there is a 2 ratio. So there is 200 at the ratio of 200 to 150. Okay, so equal 4 to 3. So you can say, when you make this ratio simplest one, as I told you, the ratio should be expressed in the simplest integer. It ends up 4 to 3. How can you sure if this is an answer? You can confirm this answer whether it is correct or incorrect by multiplying inward product, which is 150 times 4 equal 450, right? No, I'm sorry. 600 should be equal the 200 times 3, which is 600. So this answer is correct. So the ratio of the 200 to 150 must be equal to the 4 to the 3. Proved by this rule, inward product is equal outward product.